Welcome to Summarize Science, where we break down the latest breakthroughs in technology and space. Today, we are looking at how researchers used a new open-source tool called CosmicDancePro to see what happens to satellite internet during massive solar storms. The May 2024 solar superstorm was one of the strongest in decades, and it provided a perfect case study for how vulnerable our space-based networks really are. These solar events are becoming more frequent because the sun goes through regular cycles of activity. We are currently in a phase where the number of sunspots and intense solar flares is on the rise, increasing the risk of geomagnetic storms hitting Earth. When a solar storm strikes, the sun blasts out a cloud of charged particles that travels at thousands of kilometers per second. As these particles hit our planet, they cause the Earth's upper atmosphere, or thermosphere, to heat up and expand significantly. For satellites in low Earth orbit, like those operated by Starlink, this expanded atmosphere creates intense drag or friction. The researchers found that during a superstorm, atmospheric density can spike to 20 times the normal level, literally slowing satellites down and making them fall. This leads to what is called orbital decay, where the satellite loses altitude very rapidly. To prevent them from falling too low, Starlink's automated systems have to perform real-time maneuvers to push the satellites back up into their designated orbits. The study identified a strange W-shaped pattern in how satellites lost altitude across different orbital planes. By analyzing global density maps, they discovered that this pattern is driven by the massive difference between the day and night sides of the Earth. The sunlit side of the planet has a much denser atmosphere, meaning satellites passing through the day side experience way more friction than those on the night side. This effect isn't just a storm artifact. It happens every day, though intense space weather events amplify the variation to extreme levels. Beyond physical movement, the study looked at how your internet connection actually behaves during these solar events. They found that network latency, the time it takes for data to travel, spiked significantly during the peak of the storms. In some cases, users experience repetitive, short-lived outages and reconfiguration latency spikes that jumped above 500 milliseconds. This means your interactive apps, like video calls or gaming, would feel much less responsive or cut out entirely. One of the most interesting findings was that the uplink, the data sent from your dish to the satellite, is much more sensitive to solar activity than the downlink. The researchers saw uplink packet loss increase by up to 60%, even while the download connection remained relatively stable. For the average user, this translated to a noticeable drop in overall data rates, often by more than 10 megabits per second during the peak of the storm. Public speed test records showed that these performance drops were felt across the majority of global regions served by Starlink. The study even noted that operators might use these storms to help drag decommissioned satellites out of the sky more quickly. However, for the satellites we rely on, these storms pose a serious challenge for maintaining a stable and fast global network. To recap, solar superstorms heat up the atmosphere, creating friction that physically pulls satellites down and interferes with their high-tech laser links. This creates a double threat of potential orbital collisions and degraded internet service for millions of customers. In the future, as we launch tens of thousands more satellites, building networks that can withstand the sun's temper will be essential. Tools like CosmicDancePro are paving the way for better resilience in our space-based digital infrastructure. Thanks for watching Summarize Science, and stay tuned for more deep dives into the technology shaping our future.